So I'm going to start somewhere completely separate from Shakespeare, because it sort of explains a bit what my motivation for thinking about Shakespeare is. I'm an applied mathematician. Okay, I'm not a Shakespeare specialist. I'm not a historian. And I see something like that. This is spider's web after rain, looking through towards my front garden. And it's just beautiful. But because I'm a mathematician, I start thinking about it. And look, the droplets, you've got separate droplets. Why aren't they all falling down to the bottom? Why are they the sort of size that they are? Surface tension is obviously important, but I sort of think, well, spiders' webs are sticky, so they not fall down because they're sticky, the stickiness. But then some of them might go into each other. Why the regular spacing, or apparently regular spacing, of a lot of them? Maybe spiders put little dots of, and so that's stopping things going in. I don't know. It's not my area, but it illustrates the sort of thing a mathematician starts looking at the world, and all these things go woo, 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 woo. Maybe this, maybe that, and maybe somebody knows the answer to that question. I haven't bothered to get the detail, but I find it that I can't stop thinking about these things. And this is what I sort of think of as a sort of mathematical eye. You look at something and you see something through a mathematical lens. Now, my contention would be everyone has that. It's not particular to mathematicians, it's just I have a certain type of vocabulary that allows me to talk about it in a way that sounds very impressive. And for a lot of people, they just say, oh, look, but it is interesting, and I don't really understand why that happens. Clearly there's something going on. So this is a sort of universal thing that we have in trying to order, make sense of and make order in the world around us. And so this has been something I've been thinking about for a while and trying to work out ways of articulating it. And so after several false starts really trying to think about things now, I realized that a lot of what I wanted to say, a lot of what I wanted to think about could be done through Shakespeare. And it's really an intersection of two things. What do people think they know, and how do they think they know it? And how do people use those ideas and express them, play with them, particularly for me, through a mathematical lens? And that's around technology, it's around knowledge, beliefs, and that's just pervades drama, poetry, the arts. And so I think it's an interesting way to look at things. And having said what it is, I should say a bit about what it's not. Okay, I don't want a description of, I'm not going to do a reductionist thing of Shakespeare as a scientist, he wasn't. But he was living at a particular time with particular technologies and evolving technologies. And scientific ideas, popular scientific ideas were around, and I'll talk a bit about that a bit later. The other thing that it's definitely not is a narrative about how we're getting cleverer and cleverer and cleverer at doing science. Okay, I'm sort of not really interested in that, ooh, and we understood that, ooh, and we understood that. Okay, I'm much more interested in just the way that people sort of play with ideas and so on. So the specifics then of why Shakespeare, first and foremost, it's just fantastic. What an excuse to sort of have to? I don't have to, I want to read Shakespeare, look at Shakespeare's plays, think about them, reflect on them. You've got characters from a broad set of backgrounds, social backgrounds, genders, being articulated. And obviously, there are issues about how much Shakespeare knew about the different groups of people, and I don't want to get into that. My idea is that Shakespeare's work basically gives me a world in which to play. Okay, so it's a selection of words, he's chosen them in various ways, he's depicting people in various ways, and that gives me something that is a sufficiently large body, I think, for me to actually get quite a lot of different things going on, and sufficiently finite that I don't get completely lost. So that's one of the reasons for Shakespeare. The other reason is I actually think the historical distance gives me exactly the sort of thing I'm trying to get at when I'm thinking about how people think about things. Because the historical distance means that there's a lot of stuff that is alien when talking about stuff which is completely familiar. Okay, because their experience, their knowledge system was sufficiently different that you come up and think, oh, you know, what was going on there? Why would somebody say that? And so you have to work a little bit to try to see what's going on. So I think that sort of alien and familiar to me is really quite an important thing. So I think there's another thing that really irritates me, but which isn't really part of this, which is I get very fed up with the way that science and technology and the arts are treated as completely different. And so I wanted to do something that was at least an attempt to put those things together. Right. Bit of what I call intellectual housekeeping. The version of Shakespeare that I've used most is the Oxford Shakespeare, the complete works. The film clips are thanks to the ERA, which is the Educational Recording Agency, which is something that University of Oxford is part of, University of Manchester is part of, for educational purposes, except for one, because the very first example is from the English Shakespeare Company, taken from YouTube. Again, they allow education purposes, and that's because none of the BBC versions had the clip that I wanted, which is really frustrating. And it's actually true that almost all my clips come from the 1970s and 1980s. That's not because those are the only ones available, it's because they're the only ones available that have the scenes that I wanted. Okay, so I went through a really frustrating and rather long process of saying, oh, that's a really good, I love this version. Hang on, where are the lines I want? And they jump. There are a number of books that I should mention. There's a recent book by Jessica Mary Otis called By the Numbers, which is really looking at early modern England and number systems and how ideas about number were changing at that period. It's very recent. I haven't read it all yet, but I've taken some little bits from it. The book that I'm closest in spirit to, I think, is Adam Cohen's Shakespeare and Technology, where he looks at the different technologies that are being developed, technology, industry, in the 16th, 17th centuries, and ties that in with Shakespeare. And there are two books that in some ways look much closer to what I'm doing, but I don't think they are. Dan Falk's The Science of Shakespeare is very much that idea that there are these big scientific changes. There's Copernicus, there's this, that and the other. And he's trying to map those changes onto Shakespeare. And I sort of think it's not my style, okay? Not what I want to do. And Rob Easterway's recent book, Much Ado About Numbers, where he's really interested in the manipulative, what games people were playing with numbers in particular. We have a little bit of overlap, but that's about it. Okay, so what am I going to do? I'm going to start with two examples, just to see how how people were talking about doing things and what they were doing with mathematics, and so on. The bit on almanacs and the phases of the moon, there is going to be some maths. And that maths is the maths that you were expected to do if you were using that almanac. Okay, so it wasn't aimed at mathematicians, it was aimed at, it's a bit like the manual. You know, if you, we first had home computers, you couldn't just click a button and everything worked. You actually had to connect to things and you had to do things and things like that. So it's a bit like that. I want to say very briefly a thing about three mathematicians, just so that you can sort of see that people were mathematicians. Then I'm going to look at mirrors and sunrise. And so that first part is really about how maths and technology and understanding of the world around us gets into Shakespeare's plays, but they don't really illuminate Shakespeare's plays. Okay, so it's just occurrences and what were people thinking about? What were people able to do? And I want to do two things, Sonnet 77 and King Lear, which I hope are sort of more interesting and really about Shakespeare's awareness of some of the technology and mathematical ideas around him, which weren't the big technical things. It's just the things that you would come across in everyday life. And then we've got Act 5 there, which we will see whether we have time for. It can get curtailed if we need it. So, two introductory examples, Counting the Enemy and Fine Moonshine. So the first clip is from the English Shakespeare Company from 1990, directed by Michael Bogdanoff. And effectively, what we have here, Henry V Part 2 is really about father-son relationships and Prince Harry learning what responsibility might be. He's a difficult teenager, he's got under the influence of Falstaff. You've got the sort of change going on for him, but at the same time, in England, things are not going well, and you get a rebel faction that is really quite fed up with the conditions and how the King Henry IV is behaving and the governance. So they've assembled in a Yorkshire forest, hoping that another conspirator, let's say, Northumberland, will come and join them, a rebel, and this is where they learn.
I must acquaint you that I have received new dated letters from Northumberland, their cold intent, tenor, and substance thus. He is retired to ripe his growing fortunes to Scotland, and concludes in hearty prayers that your attempts may overlive the hazard and fearful meeting of their opposite.
Thus do the hopes we have in him touch ground and dash themselves to pieces.
Now, what news? West of this forest, scarcely up a mile in goodly form, comes on the enemy. And by the ground they hide, I judge their number upon or near the rate of 30,000.
The just proportion that we gave them out. Let us sway on and face them in the field.
Well, it might be the just proportion, but they don't have Northumberland, so it's not going to end well. The point about this, two things. We learn that Northumberland's going to sort of do a little side hustle, and the messenger comes in, and it's not an easy part to play, a messenger. And he says, west of the forest, scarcely off a mile, in goodly form comes on the enemy, and by the ground they hide, I judge their number to upon or near the rate of 30,000. And so this is just a small little example in Shakespeare of how people manage things. So for a mathematician, this is easy. Amount of stuff is the density times the area. Okay, so this is the sort of thing, not a messenger, he's not carrying a message, he's actually done some scouting, he's gone out, he's looked. So he's experienced in this sort of thing, he will know they are in goodly order, so that means uniform density. And he's a very good judge of area. So he either has a little book which says density, are they in goodly order? Ooh, yes, they are. And what ground do they cover? Or he's good at judging that. But the basic idea is that you have some simple mathematical way of looking at things that says, I know roughly speaking for that sort of army marching in this sort of way, how dense they are, I know how much ground they cover, I multiply the two. Okay. You could also, there are other variants on this where you could count the number of subunits if they're marking in groups, or how the camps are pitched. You could count the number of fires or the number of tents. And actually, Julius Caesar used this in Germany. So this is an old technique. Okay, this isn't new. Okay, Julius Caesar used it. What he did was he got his army, so the Roman armies were very disciplined. You know, they knew how to pitch tents. So he got his lot to pitch them rather close together. So they covered less ground. So that the Germans sort of looked at this and just looked at the ground they covered, assumed it was standard Roman procedure, and assumed that there were rather less people, soldiers, than there actually were. And that didn't end well either. The same technique was used in the 19th century, counting buffalo herds in the USA. Trump's inaugural ceremony, 2017, there was a little controversy, and the same technique effectively was used again. In fact, it's so prevalent, it's got a name. It's called Jacob's technique, after an engineer or mathematician from the 1960s. So these things get used over and over and over again. And then now, actually, it's interesting. Despite the fact there's sort of 2,000 years that this has been used, now it's changing because we use AI. So people put drones up and AI captures it. So that's the first little example. It's just a little example of something where something comes on and you've got these words that you're not quite sure what they mean. They're actually just very simple techniques that people had to understand the world around them to make decisions. The next clip I want to do is Midsummer Night's Dream, and I'm going to show you two clips. I'm going to show you two clips because both of them, neither of them have the lines I want, and they do it slightly differently. The thing about these from the 70s and 80s was that at least they have some of the lines. The things from the 90s and 2000s, don't even have the lines. They cut, they jump. So this is really, the thing I want you to concentrate on is the almanacs which come in the middle.
We will have such a prologue. Yeah. But there is two hard things. That is, to bring moonshine into a chamber. For, you know, Pyramus and Thisbe did meet by moonlight.
Doth the moon shine that night we play our play?
A calendar. Look in the almanac. Yeah, find out moonshine.
Or else, one must come in with a bush of thorns and a lantern and say he comes to disfigure or to present the person of moonshine. Then there's another thing.
There's always another thing. So I was going to try to give you the plot of Midsummer Night's Dream, but I can't work it out. I mean, it's very complicated. It involves drugs, fairies. What's happening here is a group of what we'll call rude mechanicals are planning to stage a play, led by Quince the carpenter. And they're trying to think through how they're going to work it out. That was the 1971 version, and it jumps a line or two, and you could see the almanac, which is the thing I'm interested in, was presented and then just thrown down. Okay, this at least I've got it in there. The 1981 version.
Things. And that is to bring the moonlight into a chamber. For Pyramus and Thisbe, you know, meet by moonlight.
Does the moon shine that night we play our play? A calendar. Look in the almanac, find out moonshine.
Yes, it does shine that night.
Well, then may you leave a casement of the great chamber window where we play open, and the moon may shine in at the casement.
Or else, one must come in with a bush of thorns and a lantern and say he comes to disfigure or to present the person of moonshine. And there's another thing.
So, those of us of a certain age will recognise quite a lot of those actors. One of the great things about the BBC is its ability to bring sort of people who aren't always regular theatrical actors into their productions. But bottom, Brian Glover there, is trying, and Quince, who is the thoughtful Geoffrey Palmer character there, they're trying to work out how to get the moon into their production. And there are two ways. Either you could have the moon, and that's the almanac. Is there going to be a moon on that night? Or you could have something that sort of stands in for the moon. Okay. And so that's a nice bit of problem solving. But let's just think, because the almanac is one of those things that was really developing at that stage. It was going from, the way I like to think about it is it's almost like your smartphone. Suddenly you had access to information. So they want somehow to use this almanac to find out moonshine. And if you look a bit later than Shakespeare's period, 1641, for example, this is an almanac by Jonathan Dove. And you can see, I hope you can see, May hath 31 days, first quarter, 7 days, 45 minutes past 11 at night, full moon, 14th day, 48 minutes past 7 at night. It's quite exact. It's telling you pretty much where the phases of the moon, and you can see that below that actually there's a list of, on the first, there's some information about the astrology, the position of the stars, and then it says pleasant weather. So this is the sort of thing that you get from your almanac. In fact, you get lots more. I'll talk about that in a minute. And almanacs appear several times in Shakespeare. Another example here is from Henry IV, Part 2 again. Saturn and Venus this year in conjunction. What says the almanac to that? So that would be looking to say, what's the consequences? And so what's in an almanac? An almanac contains just lots of information. It told you about the weather, it told you the best time to sow and crop, it gave you medical information, it gave you the phases of the moon, tides, astronomical conjunctions with their astrological consequences, current knowledge, consequential history data. It's sort of a compendium of stuff that is meant to sort of entertain and educate. And there's some of them have important dates from the past. Some of them have the sizes, the relative sizes of the planet. Some of them have just lots and lots of whatever they think is interesting, and I'll actually come back to that in a minute. And so Leonard Digges in the mid 16th century, so a bit before Shakespeare's time, had an almanac where the idea, and he wasn't the only one doing this, so the idea with an almanac is it tells you about things that you need to know. Every year, those things are slightly different. So by the mid 17th century, you had around 300,000 of these things being printed each year. Okay, that's a lot. And they were printed each year because they updated the information. Some of the early almanacs, and Leonard Digges' example is a good one, he actually set things up so that you calculated, he gave you a little recipe to calculate in the year that you were interested in how to do things. Okay. But that meant he had to explain the calculation a bit. So Dove just gives you the information. But Digges has to tell you how to do things. And they're all based around some very nice arithmetic connections, which are actually related, most of them are related to the sun, moon, and earth dynamics, which I'm not going to go into. So we're interested in the phase of the moon. So I'll talk about lunar months. Strictly speaking, it's not a lunar, it's got a posh name. But the phase of the moon going from no moon, half moon, full moon, half moon, no moon. Okay, so the average month is a bit less than 30 days. That's a bit lower than most of our months. The solar year is 365.24. That 24 is really important. That's your leap years. That's dealt with by leap years, and the Julian calendar managed that. But 2.5 would be managed by a leap year. 2.4 is a bit less. So actually the Gregorian calendar, when it came in, dealt with that, which we will come back to. But the point is that a multiple, it doesn't really matter what it is, it happens to be 235, of the lunar month is almost exactly the same as a multiple of the solar year. And that means that, and it's actually, the number of solar years is 19. So it means every 19 solar years, you sort of reset the phases because you come back to the beginning. Okay. And there's also a shortfall of 11 days in the lunar year compared to the solar year. And this is what, so I'm not going to go through this in detail, but this is basically what DIGS gets you to do. There is a thing called the prime, which is not a prime number, it's the prime, it's sometimes called the golden number, which tells you where you are in that 19-year cycle. Okay, so you know that the first, so you've got, you have some starting cycle, and you know that it's going to repeat every 19 years, which means you have to sort out those, where you are in that cycle. You also then have to, you've got this 11 days shorter, so roughly speaking, if you're in the third time, if your cycle starts 1st of March, say, and you're 5 years later, there are 5 times 11 days, which shorter, so you're 55 days on than you thought you were. And you divide by 30, so you multiply by 11 to get the number of days, divide by 30 to get roughly speaking, the number is 29.53. Roughly speaking, the remainder gives you where you are in the on the 1st of March, where you are in the cycle. Then you have a thing called EPACT, which basically counts you on to get something else. I'm not going to go into this, but basically you have a calculation that you can do it. You can do. Sorry, the EPACT is what? Sorry, it's what I just said. It's prime times 11 modulo 30. So, and you have a table that helps you sort of orientate yourself. But it goes from 1 to 19. Now, so what's your start date? Because if your prime is 1, then you multiply by 11, so you're 11 days on. So you must have been the previous one that was your start date. But that was 19. They've avoided using 0. They're using 0 in the numbers. 1560 has a 0 in it. But they're not using 0 in the calculation, or the indexing of the calculation. I hate indexing. All the mathematicians will know indexing is a complete pain. Whether you go from 1 to n, or 0 to n minus 1, really matters when you're trying to write something down clearly, and there often is a better way of doing things. Anyway, that's a side issue that mathematicians know. But 19 is sort of 0, so 19 has to be, what do? I do 19 times 11 and divide by 30. Well, if I do 19 by 11 and divide by 30, I've got almost 7. So I've got 7, remainder, almost nothing. So the remainder is nothing. Okay, up to the accuracy that we're doing these things. But it wasn't written down. It wasn't, they didn't give it a 0, they gave it a 19. 19 is playing the role of 0 here, but you have to calculate that. So let's go on. So you can now think of this scene where they bring out the almanac and they scratch their heads a bit and they've got to work out what it is that they're trying to do. But that takes too long and it's not a very important part of the story. Right, 3 mathematicians. I want to do this very, very quickly. This is the wiki version of... So John Dee is wonderful, and you should go beyond wiki. I encourage anyone to find out anything, or one of the fictionalized versions. There's lots of things about John Dee. Possibly modelled Prospero in The Tempest, but he was a really flamboyant mathematician. I said that he's an early celebrity scientist. Okay, he went around impressing people. You can see him here, he's impressing Elizabeth I with some amazing light show. And he was an appropriator, he was interested in everything, he had an amazing library, he died a pauper because, well, he got on the wrong side of too many people. But he also wrote a preface to the first translation into English of Euclid's Elements. And that, even now, is an absolutely fantastic manifesto for applied mathematics. And so I'm going to come back to that in a minute. Leonard and Thomas Digges, their father and son. Leonard was possibly the inventor of the theodolite, possibly the inventor of a telescope, because he was a surveyor. So he would have wanted to be able to find things. He also didn't end well, although it wasn't really his fault. Thomas Digges, his son, early adopter of I'm going to mention Copernicus twice. That's the first, well, it's not, it's really, strictly speaking, the second, but that was in the introduction, so that doesn't count. He was an early adopter of Copernican theory, which we'll come back to, possibly. Taught by Dee, there's a close relationship with him. Interesting, his wife, Anne, remarried after his death to a man who became an overseer of Shakespeare's will. So there's a connection to Shakespeare. His son, Leonard Jr., I don't think they called him Junior in those days, actually was a poet and probably, I mean, there's a lot of scholarly stuff that sort of seem to say that there were quite strong connections between Shakespeare, certainly moved in the same social circles as Thomas's son, Leonard. So there's a connection to Shakespeare. They lived relatively close by in London, so that's good. And so here we have the preface. So Billingsley, who had been a mayor of London, did this English translation of the Almanac, and it says, this is a fruitful preface made by Dee, specifying the chief mathematical sciences, what they are and whereunto commodious, where also are disclosed certain new secrets, mathematical and mechanical, until these days greatly missed. So, what did Dee do? Well, he basically laid out, he had this ground plan for mathematics, which starts with what we would now call pure mathematics. Actually, probably wouldn't. I'd much prefer not calling it pure mathematics, but fundamental mathematics. Arithmetic, geometry, and mixed, where you put arithmetic and geometry together. And then he has a list of what you use this stuff for, and to some extent how you use it. So perspective, astronomy, music, cosmography, astrology, statics, anthropography, measurement of the human body, and a whole lot more, which are really interesting. This is what he was interested in. He has examples of them. And the last one was meant to be the highest form of mathematical art, is archimestry, which was linking basically mathematical theory to experiment. So it was making that connection to the theoretical view of life to the experimental view. But it's really worth having a little, it's very easy to find on the web, really worth having a little look at that if you're a mathematician, just to see how the pure applied divide to some extent was even happening here, but that the highest form of mathematical art was putting the two together to some extent. So anyway, I want now to move swiftly to two examples, mirrors and sunrise. So I want to do this very quickly because we're running out of time, and I want to show some things. So mirrors, this is part of the revolution in technology that was going on at the time. So the Romans had been very good at making mirrors. That had been lost, and in the 14th, 15th centuries, certainly by the early 16th century, glass mirrors had started being produced in quite a large scale in Venice, and they could be made quite small. So actually the early ones were quite convex because they were very good at blowing bottles. So you blow a bottle, you stick some mercury and I think it was tin into it, slosh it around a bit, cut it open, and you've got a mirror-ish. Okay, it's a bit more complicated than that, but the thing of applying it to a sheet was harder, and that took a bit more time to do. But by the 16th century, these hand mirrors were pretty much everywhere. And if you think about this, I think of this as a selfie. This is the equivalent of the selfie, because suddenly you're able to see yourself in real time. So rather than having before it would have been some burnished metal or something like that, obsidian, or a static, you might have been, if you're rich enough, a static mirror, a large mirror. But now you can carry this thing around. You can be in church and just check your makeup, whether your hair's looking good, and actually see yourself really quite well defined. My mother, in her book Electricity, has a line about when the first electric lights were put on in rooms, and suddenly you were able to, this harsh light went into all the dark corners, and you could see things that you'd never thought about what was actually happening in that corner. Well, it's the same thing here. You can suddenly see things, and there was quite a lot of moral outrage. I mean, in France in 1575, this quote comes from, "Alas, what an age we live in to see such depravity as we see, that induces them," i.e. women, "even to bring to church these scandalous mirrors hanging about their waists." So that the worry was that people would spend the whole time looking at themselves. But it does revolutionize the way that you see yourself and the timing that you can do that, and that you can actually compare good versions of your versions that you can see with what you can see on other people. And you can see that's a really, they really took off around this time. And Dee, of course, was not immune to being interested in mirrors, but he liked the idea of a cylindrical mirror, a mirror that deformed things. And actually, part of the thing about this was sending messages that nobody else could read, because you could only read them with a cylindrical mirror. And so that's another thing. Now, I'm not going to show you the whole of this clip. This is Patrick Stewart as Macbeth. I think I'm not going to show the whole thing for time.
Is this a dagger which I see before me? The handle toward my hand. Come, let me clutch thee. I have thee not.
But I'm not going to go through it in all. But of course, Dee knew a man. He would. And in the preface, he talks about being able to go to a friend in London, where he will set you up and you will lunge with your sword, and you will see a sword coming back into your face. All done with mirrors. Okay, and so Ian Wright in 2005 wrote a very nice little piece suggesting that, what's in the air. First of all, the preface, the Euclid's Elements was that version had quite a large circulation. The preface, therefore, would have had a large circulation. And so the things being in the air, so Wright is suggesting that the idea that you might see something that's actually almost real might have given Shakespeare some of the ideas. I mean, and it's certainly an interesting idea. But it's that thing of what's in the air, not necessarily that it was the immediate thing, that people had certain images around them. And the thing I like about this, of course, is everybody knows this is Pepper's Ghost, which is a 19th century phenomenon. So it was used in plays in its simplest version. I don't know why the arrows are going this way. It should, in a sense, go the other way. But you have a plate glass which is dark enough on the right-hand side here. That's quite a lot of the light that gets reflected, or quite a lot of the light that remains gets reflected. And you see what's on S as though it was on S primed. Okay, so you're seeing, your mind is interpreting it as S primed. And with my daughter Ursula, we did this a couple of days ago, was we have a large window onto the garden, and as it was becoming dusk, we lit Ursula's hand holding a knife with an iPhone, and the reflection off the window we could see with the garden behind it. And it's exactly the same principle. So it's a bit pre-Raphaelite, I think, rather than early modern, but the principle is the same. Okay, so Julius Caesar is there's so much about atmospherics, comets, weather, and so on. And Casca, so you have a conspiracy against Julius Caesar. Casca is one of the conspirators. Cinna says, oh, pardon, sir, sorry, Decius says, here lies the east, does not the day break here? The important thing is that Casca says, no, you're wrong, because here as I point this sword, the sun arises, which is a great way growing on the south, weighing the youthful season of the year. Some 2 months hence, up higher towards the north, he first presents his fire, and the highest east stands as the capital directly here. It's sort of meaningless to us. Can you imagine doing that, asked as a 16-year-old to do that? You go, point, 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 point. Not quite sure what's going on. But to someone who lives not in a city or where buildings are much lower, you'd be really quite aware of where the sun rises. And you would know that it doesn't rise in the east. Okay, it does, twice a year. But it moves. The position of the sun moves. This picture shows the position of the sun over the year at 12 o'clock noon. And it's very famous analemma. But there's a similar sort of thing with where it rises. So it rises, I'll always get this the wrong way around. It rises in the southeast, don't know why I'm pointing that way, in the winter solstice, and the northeast in the summer solstice. It's got really quite a large variation. So what Casca is actually saying is you've got the timing wrong. Okay, this is where first of all, this is where it's rising, and that's not the east because of the time of year we're at. Okay, so you can unpick it that way, and Christian Dahl actually does quite a nice job on some of this, and his line is also that you can equate the sun with Caesar. So Casca is the one that sees Caesar first because he sees the sun first, so he strikes Caesar first. So it's sort of pre-telling the story of the death of Caesar. But there's another side to this, because when you really go into it and try to interpret this for March the 15th, Ides of March, then the seasons aren't right for what he's saying. And there's a really nice thing both Shapiro and Dahl play about the role of the anxiety about the two calendars, the Gregorian and the Julian calendar, Julian being in the UK, Great Britain, Catholic Europe taking the Gregorian, meant that there was a difference in days between them. And there was also a difference in New Year. So the New Year in Julian was, I think, the 25th of March. In the Gregorian was the 1st of January. And I had a note of it somewhere. The legal beginning of the year moved, it was the legal, 25th of March was the legal New Year until 1752, when England finally chose to join the Europeans. And so I think that there's a sort of very clear thing in Julius Caesar of anxiety about time, and I think this is another example of it, though I don't have time to go through it. Right, I'm going to do one of these. Which one am I going to do? Okay, let's do sonnet 77. So I told you already, mirrors were the new techniques, and they were being used everywhere. Almanacs, huge increase in availability of knowledge, huge increase in numbers printed and availability, but also timepieces. There were new portable watches, portable sundials were available, spring mechanisms were starting to be introduced, so watches were also really changing technologically. So Shakespeare, I mean, just anyone who was there would know that these things were happening. So sonnet 77. Thy glass will show thee how thy beauties wear, thy dial how thy precious minutes waste. The vacant leaves thy mind's imprint will bear, and of this book, this learning mayst thou taste. The wrinkles that thy glass will truly show of mouldered graves will give thee memory. Thou by the dial's shady stealth mayst know time's thievish progress to eternity. Look what thy memory cannot contain. Commit to these waste blanks, and thou shalt find those children nursed, delivered from thy brain, and to take a new acquaintance of thy mind. These offices, so oft as thou wilt look, shall profit thee and much enrich thy book. So, three things there. The glass, to see clearly, the looking glass. The dial, to measure time. And the blanks. So almanacs, I told you, you had to do calculations on some of these things, and you might want to take notes. So almanacs fairly rapidly developed the idea of leaving some pages blank so that you could write in them. And actually, in the English Civil War, people were using this to, people have analysed almost diaries, I mean, it's effectively diaries of things that they've done according to the almanac. And so this is the mirror, the portable watch, and the almanac, all in one, all great new new technologies. And what I really like about this, I could go on for quite a long time and I don't have time. This is, compared to most of the sonnets, this is really optimistic. Okay, a lot of the sonnets are, oh no, I'm getting old. I've got a wrinkle. You've got a wrinkle. Will you still love me? This is not that. It's actually, these offices, so oft as thou wilt look, shall profit thee and much enrich thy book. Not make you feel rubbish, but actually enrich you. And so I would see this as really quite it's first of all, it's the white heat of technology sonnet for Shakespeare, and it's really, I think, quite positive. It's saying, yes, things change. Yes, things are different. Yes, you forget things. But actually, there's stuff here which will help you age, help you manage that change. So the thing that I'm not going to talk about, which is a shame because I like it, is King Lear, which has an awful lot of nothing. And we could talk about naught quite a lot. We saw naught and the point about the nothing is that it was coming in and Roman numerals were on their way out. You saw in the digs 1555 that 0 was being used, but not as a number. He was using 19 times 11, the remainder thereof, to talk about 0. And so we can think about King Lear, who makes a really bad life choice. He sort of basically asks his daughters whether they want to take over the kingdom. 2 of them say, "You're wonderful, we love you lots. Yes, of course, give us all your money." The other one says, "Well, I love you as my duty requires, and that's fine." And so he gets very fed up with her, and things go apart. But I like the idea, he does hand over his kingdom, so he becomes a placeholder, and that's an early idea of, very early, I mean, going back to the Babylonians and Mesopotamia, idea of 0, where it just tells you that there's not a 10 or whatever. Madness, you actually go from a placeholder to being nothing, and then you can become something again through death, where he becomes a historical king. He becomes a number, position. So just to conclude, I think this is Shakespeare's I just so love looking at Shakespeare, so that's nice. But also it gives you this slightly alien view of the way people are managing information and mathematical ideas in their ordinary life. So there was massive technological changes going on, and that's reflected in the writing. And I hope, the last example gives you a sense that if you know a little bit about those technical changes, it does change the way that you see some of Shakespeare's work. And I did realise when I got to the end, I hadn't told you when he lived. So here's some dates to finish. Those are numbers, and there's not a 0 amongst them. So I will stop there. Thank you.